Boom. Okay. So first, I just wanted to start off with just another review of Express. It's tied in with Node, obviously. With Node, if you wanted to do what Express is doing under the hood, this is essentially what it would look like. We would have to send headers back. We would have to do all of this like error checking and stuff like that. Obviously, there's a lot of stuff going on here. It's kind of hard to read if we were just doing it with Node vanilla. So Node is great, a little bit of humor here, except for the parts that aren't. Obviously, if we had to do that for all of our routes and everything, it would kind of get cumbersome. So Express is going to help us by removing a lot of that work that we have to do and just allowing us to just jump right in and create a lot of routes very easily. So because of Node being complex, we're going to be using Express. So obviously, I'm sure a lot of you are used to this now. It's a lot more cleaner, it reads a lot easier. We can all understand kind of what's going on, even just at a glance. So Express is great. It's to Node as jQuery is to the browser, so it's essentially like a framework that helps you just get things done a lot quicker. And it gives you more control. Express is a web framework for Node that is lightweight and unopinionated, which leverages middleware to help you create robust applications. Express is a web framework for Node. So like we were saying, it provides abstraction and making it so you don't have to write those enormous lines for every single route. It takes a lot of that out for you. And it doesn't have a lot of functionality built into it, but what functionality you do want built into it, you can import with middleware, which I'm sure we are all familiar with, as Mitch lectured about 2 days ago on that, maybe a day ago, yesterday. Losing track of time. So middleware, in essence, we've seen that it's essentially functions that we want to run in between the request and the response. So here we have the example that Mitch kind of showed us earlier, where we're saying in between the request and the response, we want to just console log what we're getting. And then, of course, we're going to export that using module.exports, and then we are going to require it in our server file and then use it so that it's console logging in between the requests. All right, some middleware baked in, like Express Static to serve static files. Typically, you'll find and install Express middleware via npm. You can leverage middleware to build out routes and API endpoints using HTTP verbs. So once again, we've all seen this. The Express documentation goes a little bit more in depth about all the different versions that you can use, but I'm sure we're all familiar with that. So that was just a quick briefing on Express and helping refresh our memory on that. But as far as data storage, we're not going to be talking in depth about databases today, but maybe just a little bit, just to kind of like touch on it and give you guys a hint of what to expect. So data persistence is what we're going to be talking about, and that's essentially retaining information after the program lifecycle is terminated or completely done. Pardon me. All right. So obviously, if we're running a function or a program console logging something, it's only there in memory. And when we say that, what we're trying to, what we really mean is it only exists in your RAM, in your random access memory. So RAM is essentially used by your computer to store, data that it needs at that certain point, but it doesn't anticipate having to actually hard save it or need it for future reference, essentially. RAM is there solely for your computer to just kind of throw things out there so that it's like, okay, I'll handle this later, I'll put that over there, okay, cool, we're allocating this memory towards this variable, awesome, and then once that functionality is terminated, once it's like, okay, we don't have a reference to that anymore, it's just erased forever. And that RAM is then available to be utilized to store other data temporarily at that point. And so that would be called volatile storage. And so what we want to do is save the volatile storage and non-volatile storage. So we're saving that program state in RAM to an actual hard storage medium, I guess you could say. So this is kind of what it would look like. Here we have our program with a function that's doing something, and then we have the state of the application. So in our RAM, we have a chunk of memory that says we have an object with a key that says name and then a string that says Fred. But if we were to shut down our program while this function was running or it had that state, then it wouldn't retain that information. So what we have to do is we have to write it to non-volatile memory, which would be something like a hard drive disk or a solid state drive, where you're actually retaining it because it's hard written into the storage device even after the power is gone. So then shut down, it's still there, it's non-volatile, we don't have to worry about losing that information. And then after we want to maybe re-access that data, we'll run our function again, and then we'll read out of that non-volatile data, and we'll get the state first, and then feed that into our program, and then obviously we can have functionality back and forth with that. I'm sure some of you are familiar with that if you're caught up with the curriculum entirely right now. But this is essentially how your computer would take RAM that it's dedicating to this specific function on top and storing it for future access and reference. And of course, you can also have multiple functions and multiple states all referencing this non-volatile memory at the same time, as long as it's reading it correctly. So why two systems? Efficiency, obviously. Volatile storage is data that is not retained when powered off, as I said. It's extremely fast but expensive, and RAM is the one that we all know. So, the more RAM you have, the more room your computer has to essentially throw a bunch of variables into that storage, but again, it's not permanent. So we want to make sure that if we have something that we want to store, we are going to store it in permanent memory. And so that's non-volatile storage, and then it's retained through a power cycle because it's hard written onto either the disk or the solid state drive. But it's extremely slow and inexpensive. Inexpensive is obviously good, but the fact that it's slow means that your computer can't necessarily utilize it as RAM. That's why we have dedicated RAM slots and we have RAM sticks, is because it's a different type of memory than like solid states or hard drive disks. So although it's slow, it's obviously much more useful for retaining permanent information. So data persistence refers to the capability of retaining program state beyond a program's current life cycle, such as termination due to loss of power or computer shutdown. It's achieved by saving a program state in non-volatile storage medium, such as a hard drive or flash memory, which is also a solid state, in case you didn't know that. Data persistence requires a conversion from in-memory program state to a serializable data format. And we've been working with a serializable data format called JSON, so we're all familiar with that. So essentially, what we're doing when we're writing and we're reading from this file is we're using these methods that we're all familiar with, like json.stringify and json.parse. So this is serializing our data and making it so that as we're storing it, we have some way to read it in our JavaScript program after the fact. If we don't json.stringify it, your computer's not really going to know what to do if you're trying to read it, especially using json.parse. So by json.stringifying it and putting it in that universal serialized format, we're able to anticipate that we can parse it out and then continue on with JavaScript functionality even after it's saved in hard storage. So this is what it would look like as far as saving data into long persisting memory. And so essentially it just completely breaks everything down. It remembers that var message is equivalent to this object with the keys, Fred, hello, lobby, and it's represented by those four objects and stored somewhere in the heap. So essentially what this is saying is, right now, this is all stored in RAM in various blocks of memory. It's incredibly hard to read if you were going to try and actually look under the hood and see what this looks like. It's essentially assembly code, which is saying this block of memory is dedicated to all of this binary information. It's really hard to read. So what we're going to do is take a snapshot, essentially, of what the RAM looks like in that state and store the values of that memory. So yeah, we can save all that. We do it. And then obviously now we have written that to hard memory in that JSON serialized format, so that way when we need to access this data again, we can just json.parse it and know that we are using it in a JavaScript friendly format. Restoration, we're taking it out. And now we are going to be restoring the keys and values, in a similar state object. So it's actually not going to reserve the same memory blocks. It's going to find other memory blocks that it can fit in there instead. It's not, just because it has the same variable names, the same keys, and the same values doesn't mean that it's going to be stored in the same place in your RAM or the heap. So once we have this recreation, we can assign it to the variable message again, and we have access to that data that we wrote to our hard storage. So it's not easy, according to the slide. It becomes a challenging problem when it's impractical to write all of our state on every single change. So if we have this huge, enormous application, and every single time a user makes a post request, we have to bring in this enormous file and then go through the entire thing and add information in that object. Obviously, if 100 users are doing that over and over again, your server is going to start to have a hard time handling all those requests and accessing that data in a timely manner. Obviously, at a certain point, we will reach not being able to store all of that immense data inside of RAM. So once we hit that point, you're kind of SOL, because if you've been anticipating just pulling that file in every single time, you're going to hit this wall eventually where you can no longer do that. And so now all of the functionality that you just wrote is essentially useless. So we need the information to be addressed in multiple ways, and time complexity is an important factor. So like I said, just with hundreds of users making requests, if you had to bring in an immense file and parse it and go through and specifically add a key with values, that would add a lot of time complexity to our actual server functionality. It would take a lot longer to do this than if we were using like a database, for instance. More than one process needs simultaneous access, which, as we know with JavaScript, is tough because it's single-threaded. So more than one process operating on the single data file would need to be done in a single-threaded fashion. So obviously this is going to slow us down even more, because now we have to wait for each function to finish its operation before we can go down to the next one. And some changes might result in an inconsistency of state where one variable might have the value that you're looking for, and then it gets mutated and you didn't realize it, and then you store it that way. Now all of a sudden you have this error in your text database, your text file, which is going to persist. So obviously, as this keeps going on and there's more and more errors put in your text database, you'll essentially hit this point where you have inconsistency of state. You don't know what's going on with your variables. Everything is not working how you thought it would, and you're in this horrible place where you're like, why did I choose to write all of my data to a text file? And obviously, if we're pulling in information and iterating and all that, and all of a sudden, as this functionality is going through, your server got shut down for some unexpected reason, all of that memory that was dedicated to executing that function is now gone because you lost power to your machine. So all of the changes that were in progress while that function was running are deleted, and that's of course going to come back to changing the state in an inconsistent way. So this is obviously not the most ideal way to be storing data, but for right now it's good to know just to understand how to access local files and knowing how to store JSON and all that. So databases, like I said, we're not going to be going too much into this, but to just give you an idea, DBMS is a database management system. A database is a collection of data organized in a way that models aspects of reality in order to support processes that rely on that data. The term database is often conflated with database management system, as I just said. And so it's software that exposes an interface for interacting with a database while abstracting the complexities associated with the data persistence. So once we get to this point, we're not really going to have to worry about mutating our state necessarily, because it'll be its own abstracted database where we're going to be using a different language in order to store information in these, I guess, it looks like an Excel spreadsheet, but we call them tables. And that is where your data is going to persist and constantly be written to. And let's see, okay. Funny, we're going to be using Postgres. This says MySQL, but in the future we're going to be using PostgreSQL. So if you wanted to read up a little bit more on that in your free time, by all means. Not all databases are created equal. Remember that list of database persistent challenges. There it is, in case you forgot. Databases can solve those problems to varying degrees, but you have to pick the right tool for the job. So ACID, atomicity, consistency, isolation, and durability. Compliant databases offer more data persistent guarantees, but at a cost of increased complexity. So obviously this isn't going to be as simple as storing your information in RAM. It's going to be a little bit more involved, and it's going to have essentially two different technologies communicating with each other. So it's not going to be as fast as just writing hello to a text file, but obviously it's going to give us that guarantee of data persistence that we can rely on. No SQL databases, we're not really going to go into that, but essentially it's just a differently formatted SQL. Well, let's see, it's not SQL. It's a different way to store data in a database, essentially. It's a non-relational database, whereas SQL is a relational database. Some databases only operate on already persisting data or might persist on multiple versions of data. Boom. So I'm not going to go into part 2 on that just because we're not at that point yet, but just to give you like some insight into what we're going to be doing to alleviate the problem of having to store memory and stuff into text files. That is going to be the solution later on this week or maybe next week. Any questions on any of that? Awesome. I don't have a lot for you guys as beyond that. One fun thing I thought I would show you guys is your files don't actually need to be named .json. .json is essentially telling your file browser that, boom. So .json, that file extension essentially refers to instructions for your file browser to understand what that file is meant to do, but it doesn't necessarily need to have the extension .json. It's simply just storing text. So if we come in here and we change these to text, if I could spell, and then we come over here to storage.json and we rename it, enter. Now it's just a normal text file. So if I start writing, some sort of JavaScript object, it's not colorized. Now all of a sudden, the file browser doesn't know what this, well, it does know what the file is, but it's no longer colorizing it or annotating it as if it was a JSON file. So that's the difference between a text file and a .json file. Is when you load a .json file, your file browser as well as your IDE understand that that's the intent of that file, is that it's for JSON, but it's not explicitly required. And so now, oh, I should probably spin up the server. Boom. So here we have storage.txt, right? And if I did everything correctly, we can come to Postman. And so obviously here, that's not a good email address and that's not a state, but I was just testing it out, making sure that it worked. But sure enough, if we hit send, we get unexpected end of JSON input. Which is a problem with my code. Try that. I had it working at one point, and then I tried implementing callbacks, and that didn't end up working too well, so I reverted it back to a previous state. All right. So what we're going to do is we'll just do this. Overwrite the data for now. I think that's what's messing it up. Nope. Okay. Well, I apologize. This was working. What's up? I had this working earlier where I changed the name of my storage.txt file to just storage, from storage.json to storage.txt, and it worked perfectly fine.
What's in storage.txt right
No.
now? Isn't it unable to parse it because there's not, just put like an object.
Oh.
Just put like an object in the text file. Yeah.
Thank you. Appreciate that. Yeah, so I guess it was trying to add it to just the empty file, which obviously didn't work. But you can see with Mitch's help, it doesn't need to be .json. Obviously, probably don't want to do that, but it literally is just storing that information as text. That's what I was trying to hammer home. Is it doesn't matter the file extension. That doesn't necessarily like mutate or change the data in any way. It's literally just storing characters. Beyond that, I did a little bit of research as far as the difference between read file and read file sync. I don't know if you guys have looked into that at all, but essentially what read file sync or write file sync means is it's the synchronous operation of that function. And so essentially what that means is it's a blocking function. So if we were to erase this, it would error out because now we need a callback at the end of this. So here we would have to have some sort of function that executes the functionality that we're looking for. But the reason that we have this differentiation is because if you have a synchronous operation inside of your function, it's going to stop all other functions from executing until that one is done. So by removing sync and adding a callback to the function, we're able to call it asynchronously and not stop the rest of the functionality of our application if that's what we're looking to do. I was trying to get that working in my personal time. I got like a janky version of it working, but unfortunately I wasn't able to completely get like all of it working in time. But that's the bare minimum difference between read-write file sync and just read and write file. Is synchronously it's going to block all of this from happening until I get my results from storage up here. In the future, this won't be a problem because we will be working with databases, but it's good to know and understand now that if once the compiler hits this line and we execute that, it's going to stop all other operations from occurring until that one evaluates. Other than that, I don't have a whole lot. If you guys have any questions, both me and Mitch are here, so probably be a good time.
Is there a way to like, there's an implementation of like those things like with just straight promises?
Yes, there is. Unfortunately, I didn't have a lot of time to look into that, but I know that it does work with promises. It's in the documentation. Let's see. So, what are we working with? FS. Oh. So at the bottom here, we have the promises API, and so these are all functions that are based upon returning or working with promises. So it's definitely possible, and it's implemented here. There's a ton of methods, so I'm not going to go into every single one of those, obviously, but if you were so interested in figuring out how you could incorporate these, Node actually has really good documentation on all of their modules, so I highly recommend if you wanted to look into this, by all means, check this out, but yeah, it's definitely possible. Any other questions, guys?
What does express mean when it says it is unopinionated?
Unopinionated, that's a good question. Mitch, you want to enlighten us?
It's trying to say that it's not making a defined decision about architecture. That this is a tool that you can use, but in terms of architectural paradigms, we're not choosing for you. I don't 100% agree with it because I feel that if you're working with Express, okay, so maybe trying to say is that you can use it for a variety of things, right? You can use it as just an API, you can use it as an API with a database, you can use it as a processor, you can use it as something to serve a static front end, right? So it could be that. I don't 100% agree with that because if you use Express in a full stack way, which people will do later in the quarter, that is opinionated. It's a model view controller pattern.
Yeah, so essentially, like opinionated versus unopinionated is opinionated means like you have to explicitly do it the way that they created it to be made, whereas like unopinionated gives you more verbose control over exactly what you're going to be doing with that technology.
Yeah, it's a distinction between the paradigm in which you're working architecturally and the implementation.
Yeah, no problem. Thank you, Mitch. Glad he's here.
Oh, sorry.
Wow. All right, I'm done. All right, okay.
That was a joke.
Anybody else questions while you have me and Mitch here? Just about Express and what all this means, why we're doing this. Good.
Alright, guys. Oh, yeah, I'll do an announcement really quick. And so you may have noticed because he's not here today, but Ryan is no longer